Hello, this is Mr. Craig, and this is examples for day 7. And again, just like in an earlier video that I made, if you're viewing this video in 2011, I did not give you this example sheet. So I would highly recommend that you print this off and put it with your other example sheets and homework and whatnot. I noticed that for day 7 it was just the homework, and I wanted to make an example sheet to go over this to help you guys understand how to balance equations. Hopefully you understand how to balance equations, but I know that there's a few out there that still had some difficulty in general chem or in honors chem on balancing these. I want to show you a few shortcuts here. I hope this video helps. Alright, well, let's go right to question number 1. It says balance the following equation. Well, in this case here, I have given you all of the reactants and the products. And again, recall, reactants are always the things that we start with, and the products are the things that we always finish with. And in this case, I only have one product where I have 2 reactants. We do not have to have the same number of reactants and products, but we have to have the same number of atoms on both sides. Also, do realize that with chemical equations, and that's what we're doing, chemical equations today, is that the thing that we start with, like in this first problem here, aluminum, in a chemical equation, the nucleus remains the same. So on the product side, we better get another aluminum, or the aluminum should remain the same. So it's not going to change into something else as it would in a nuclear reaction. So, excuse me, and the rule there, or the law there, is the conservation of mass. So if I start off with 3 aluminums on the left side, I better have 3 when I finish. Okay, so may need to know that for later on. Alright, so here's one way that you can balance equations, and this way is a little bit longer, and some of you know how to balance equations and have your own particular system, and that's fine. That's great. But the system I'm using here is what I use when I teach general chem, and it's a very, very elementary, fundamental way of doing things. And again, it's a little more time consuming, but hey, if you get it right, it doesn't matter how long it takes. Alright, so here's what I tell my general chem students. Let's make an inventory. So write down all the things on the left side of the equation. Like in this case here, we have aluminum. And how many aluminum atoms do we have on the left side? That's right, we only have 1, since there's no value here and there's no subscript. Now, the subscript over here with the aluminum oxide, we cannot change these subscripts within the formula. If you're given the formula, you cannot change the subscript. Now, if you're writing the formula, you yourself are writing the formula, and you find out, oh, I didn't make it with the correct charges, therefore I don't have the correct number of atoms, then you can change it. However, if it's given to you, don't even think about erasing these subscripts, because if you erase the subscript or you change the subscript, you're actually changing what you have here. So if you say, well, you know, to make this really easy, I'm just going to make that aluminum a 1 and that oxygen a 2. Well, there's no such critter as AlO2 that exists and has a neutral charge. So we don't change the subscripts, because then we're changing the compound itself. Alright, getting back. So we have 1 aluminum on the left side, and oxygen is the only other element present. We have 2 of those. Alright, on the right side, or the product side, we do have 2 aluminums, and the oxygen, we have 3. When these numbers are the same, you're balanced. Okay, so it seems like, oh wow, that's really, really basic. Yeah, it is. Okay, so I don't see anything that's the same, and honestly, in this case, it doesn't matter which one you start with, but I'm going to start with, since this has no subscript, the aluminum has no subscript, I'm going to save that one for last. That one seems to be the easiest of the 2. And again, whenever you're doing balancing equations, always do this with a pencil, because you can erase and make corrections. And oftentimes, especially in general chem, I insist that you use a pencil, because you will make mistakes. Okay. So in this case, I'm going to start with the oxygen because I have 3 over here and I have 2 over here. So if I have 3 on the right side, 2 on the left side, and there are subscripts that tell me how many of these I have to have, I need to have a common value or the same number on both sides. So 3 and 2, well, it stands to reason that I'm going to put a 2 here and a 3 here. By doing that, I now have 6 oxygens, and I have 6 oxygens on this side. Hey, that's great. However, since I put a coefficient in front of, or a number in front of the formula, I'm also changing the number of aluminums. So I have to take that into consideration. Now the way that I got 6 here is that I had 2 times 3. Here I did 3 times 2. That's how I got my 6 there. So to get my aluminum, I'm going to do 2 times 4. Okay, so my oxygens are balanced. So how can I get 4 aluminum? That's right, put a coefficient 4 in front of that. Okay, and hopefully this was not an issue for a lot of you. Letter B. Here we have a hydrocarbon. How do we know we have a hydrocarbon? Because we have carbon and hydrogen. Now, I think it was day 1 or 2. I can't remember right off the bat. It's been a while since I made that video. You were asked that it'd be a good idea if you saw something like this to know what the name of that is. Okay? If you look at that and you say, oh, that's butane, hey, I've got to give you some kudos for that. Because you did pay attention to that video. You don't need to know the name for this for the test, our first test, but it's a good idea to have that memorized. I would definitely have those first 10, the anes and the enes, memorized. In this case, this is butane. Again, the generic equation is we have carbon as an X, and in this case here we have 2 times the hydrogen plus 2. If that's the case, it ends in ANE. Okay. However, for balancing the equations, that's not as important right now. Okay, so I will suggest a nice strategy for working with hydrocarbons here. Let me get back to the review there. Sorry. I always save my oxygen, this oxygen here, for last. Always last. Okay? I don't even want to try to figure out what this value is in here until I've balanced everybody else out. That's just a good heads up. Also, my second trick for this is I try to make the coefficient for water an even value. Okay? Most of the time, it's a good idea to have that as an even value. However, it doesn't always have to be. But it will save you a lot of time and a lot of stress by just saying, okay, well, I need a 3 here, but it's not an even value. So double it, and then double the other values that you've made so far. Okay? So let's go ahead and do this one. Erase that 0 there. All right, so I'm going to use the inventory method here, and I'll be honest with you, I use the inventory method on all these combustion reactions. And how do I know I have a combustion reaction? Because I have hydrocarbon with oxygen, and it produces carbon dioxide and water. And these are the 2 products that you produce. So yes, you do have combustion reactions taking place within your body. If you're not sure, feel your forehead. If it feels warm, how do you think it got warm? That's right. So you're actually generating energy with the use of combustion reactions. Pretty cool. All right. So let's write down what we know. So we have carbon, we have 4 of those. Hydrogen, we have 10 of those. Oxygen, we have 2 of those. On the right side, we have 1 carbon, 2 hydrogen, and oxygen, we have 3. Okay, so we have, on the inventory method, I want to count up all those, the same type of atoms on both, or on each side. Okay, so step number 1. And again, it doesn't matter where you start, just try to keep these in mind. Save this for last, and make this an even value. All right, so if you want to start with the water, you can. Do realize that, yeah, we have a 10 there, so to make it balanced, you'd put a 5 there. However, that would be balanced for a moment, but you would never have the correct answer. So what should we do if we need 10 hydrogens, okay, and I have a coefficient of 5 here. Is that an even value? No, it is not. So the thing that you want to do is you want to have an even version, and I say this a lot in class. You want an even version of 5. Well, double it. So make it a 10. Okay? It's divisible by 5, but it's an even number. Okay, we can't have fractional coefficients here. Later on, we'll talk about fractional coefficients. And if you're one that uses fractional coefficients to help balance, that's okay. Just remember, your final answer cannot have fractions at this point in chemistry. All right, so I've got, so let's write down what we know. So we now have 20 hydrogen. And how many total oxygen do we have? Well, 10 times 1 plus 2. That's 12. Okay, and over here, so I get the same number of hydrogen. Let's balance that out. Let's put a 2 there. So now I've got 20 hydrogen. My hydrogens look great right now. My carbon has gone to 8. Well, here's a real quick fix. Again, we want to save this for last, so let's balance this out. So I have 8 carbons over here, only 1. Put an 8 right there. So now I have 8 carbons, and so that also changes my oxygen number. So I have 8 times 2 plus 10 times 1. So I have 26 total oxygen. So everybody else is balanced. Is it possible to get 26? You better believe it. Put a 13 there. Okay. So the reason why this went smoothly is because we made water an even value and we saved the oxygen for last. Now, again, you can do it any way you want, but there are ways it can be easy and there are ways that can be difficult. It's up to you. All right, letter C. All right, letter C. Actually, I hope you remember what kind of reaction we have here. Think about what type of reaction we have. We have magnesium hydroxide plus hydrochloric acid forms magnesium chloride and water. Now, I will admit, I have written water incorrectly. The correct way to write water is HOH. Okay? In other words, it has a hydrogen and it has a hydroxide. So this is more the historical way. This is the way that you'll see water talked about, written out on the street. So when you're out hanging out with your friends and you're talking about water, it's nice to call it H2O, because if your friends aren't in chemistry, they may not understand what you're saying when you say HOH. I'm kidding. All right. So we have a double replacement reaction. And what's really cool about double replacement reactions, if you look at, oops, erase the circle there. Come on. If you look at a double replacement reaction, these are the easiest kind to balance because we have polyatomics that haven't changed. Or at least we have one polyatomic that hasn't changed. And if I look at it and identify it, there's my OH, and in water, there's my OH. And you can see that the magnesium and the hydrogen have switched places. In other words, the hydrogen that was with the chlorine is now over with the OH. Bam, water. And then the magnesium has traded places with the hydrogen to hook up with the chlorine. Pretty neat. So when you see a problem like this, oh, you thank the chemistry gods and go, this is a great question because I don't need to do inventory. You can do inventory, but it's going to take you minimum 3 times longer to do this problem if you use the inventory method. If you recognize it's a double replacement reaction and change water to look like HOH, you're going to fly through this problem. Okay? So here's how you do it, if you don't know how to do it already. Let me erase that. Okay. All right, here's what we do. We're going to, it's like a tennis match. I like tennis. I can't play tennis very well, but I like it. Pick one of these and find the ugliest one. I mean, the one that has the most subscripts within it. Well, we could either start with magnesium chloride or the magnesium hydroxide, since they have the most subscripts. Yet it doesn't matter which one you want to start with. I'll go ahead and start with the magnesium hydroxide. All right, let's put water back. HOH. Okay. How many hydroxides do we have here in magnesium hydroxide? That's right, there's 2. how many hydroxides do we have here in the water? There's only one. We have 2 hydroxides over here. We have 1 hydroxide over here. How can I balance the hydroxides? Not hydrogens, hydroxides. That's right. Put a 2 in front of there. Okay? So now I'm not counting. I'm not counting hydrogen. Please treat hydrogen and hydroxide as different. Okay? So I have 2 hydroxides. Now, how many hydrogens do I have? And again, don't count this hydrogen here. Hydrogen and hydroxide, 2 different things. So how many hydrogen do I have in the water? And again, don't count the hydroxide. So there's 2 hydrogen. How many hydrogens do I have in the hydrochloric? There's only 1. So if I put a 2 there, I have my hydrogens and my hydroxides balanced. Pretty cool. All right, so we started here. We hit it over here. Now we hit it over here. Okay? Now, how many chlorines do I now have in my hydrochloric acid? That's right, I have 2. So do I need to put a value in front of this so I come back over this way? No. And if you want to, you can put a 1 there. That's fine. I don't have a problem with you putting 1s as coefficients. You'll get used to not doing that later on. But for now, that's fine. And then the last one, we have to come back to where we started. Do I have the same number of magnesiums on both sides? The answer is yes. So my balanced equation is a 1, 2, 1, 2. The last thing that we have to check, and just what we did, like we did on the last problem, make sure you have the smallest whole number ratio. So whenever you have polyatomics, it makes life so much easier. All right, now if you wanted to do the inventory method, please do. It's okay. I don't have a problem with that. All right, letter D. Try this one on your own. Go ahead and pause the video for a moment. Okay, work this out. See if you can get the balanced equation. And then turn the video back on, or play it again. Okay, you've had enough time to try it now. I'm going to start off with the ugly one. Okay, there's my victim right there. There's the ugliest one of them all, because this one has the most subscripts. This one has 5. This one only has 3, 1, and 1. Okay, yeah, technically the hydrogen's a subscript. All right, so I want to start with the ugly one, and I'll start off, and it doesn't matter if I want to start with the nickel or the carbonate. Let's start with the carbonate, just because it's a poly. So how many carbonates do I have in this compound? That's right, I have 3. So how many do I have over here? I hope you said 1, because there's no parentheses there. So I need to put a 3 in front of the carbonic acid. Okay? So I went from here to here. All right. Now, I want to balance the number of hydrogens. So I got my carbonates balanced. So let's balance the hydrogen. How many total hydrogen do I have? That's right, I have 6. How many hydrogen do I have over here? Just 1. So put a 6. Okay, so now we've gone this way. Okay, so my carbonates and my hydrogens are balanced. Now let's serve it back over this way. So how many nitrates do I now have? I have 6. Well, how many nitrates do I have here? That's right, I have 3. So what coefficient should I put in front to make sure I have 6 nitrates? Try to 2. Okay. Then nickel, how many nickels do I have? I have 2. Come back over. Yay. Everything's balanced out. So if you want to put a 1 there, that's fine. Now, always, always, always check and make sure that these are your lowest coefficients. They can't be reduced down any further and still be a whole number. And in this case, it is as low as we can go because we have a 1 there. That's good. Okay. All right. Ooh, look at this bad boy. All right, letter E. I definitely want you to try this on your own. So do pause the video and give it an attempt. All right, you've had a chance to try it now. All right, so I'm going to do inventory. There's no way you can do the method that I showed with the polys, because there are no polyatomics on here. So I've got carbon, 11, hydrogen, 22, oxygen, 4. Now this one's a little bit different than the first hydrocarbon. Ooh, not 4, my bad. We have 4 plus 2, which is 6. Again, inventory. Got to make sure you have the same number, or the correct number on each side. Carbon, 1. And I like to keep the elements in the same order, even though they may not appear in the same order on the product side. And oxygen, 3. All right. Again, save the oxygen for last. Make this an even value. Okay? And that, again, you may not need it to be even, but it'll definitely save you a lot of trouble. All right. So let's see here. Erase those circles. Erase those circles. All right. So I'm going to start off with the hydrogen. I just like starting with the hydrogen. So if I have 22 here, how can I get 22 over here? Well, I could put an 11. Okay. That's not an even number. And I may or may not need an 11 later on. And I'll talk about that after I get done with the problem. So to stick with my rule, okay, I want an even value. So the best way to do that is 11 is great, but double it. All right, so now I have 44. Woo! 44 hydrogens. And how many total oxygen do I have? 22 times 1 plus 2. So I have 24. Okay? Let's come back over here and bounce out my hydrogen. So put a 2 in front of that. So I have 44 of those. Carbon, I have 2 times 11. So that's 22. I do have an oxygen in here. So 2 times 4 is 8, plus 2 is 10. Okay? So my hydrogens are balanced. Again, don't even try to balance your oxygens. Don't do it. You're just wasting a lot of time. All right, so now let's balance our carbons on this side. So I have 2 times 11, which is 22. So I'm going to put 22 there. How many total oxygen do I now have? Well, I have 44 plus 22, which is, what is that, 66? Okay. All right. So my carbon and my hydrogens are balanced. Now I need to make sure I have the same number of oxygen on both sides. All right. Now, what we don't want to do is just divide that by 33 and say, oh yeah, we got, or divide that by 2 and get 33, because there's a trap. There's some oxygen in the first compound. So you don't want to just automatically divide that by 2 and put your value in. All right, here's what we have. We have 66 oxygens that we have to have on both sides. So when we get done, we're going to have 66 here. However, in the first part of this problem, we have 8 of them are in the C11H22O4. So to get the correct number of oxygen, I need to do 66 minus 8, which is 50, what is that, 4? 58, sorry. Need a calculator, guys. All right, so 58, I need to add 58 more oxygens on this side. So if it's O2, divide that by 2, and so that is 26. Okay, is that right? No, 29. Daggone it. 29 would be a better number. Correct. So we need 29 oxygen. So we have 66 oxygens on both sides here. Is that right? Oh man, something's telling me that's not right. 58 divided by 2. 29. We're good. Never mind. Okay. So, in this case, we are good to go. However, there are some situations where you will have some oxygen in here, in your first compound or in your hydrocarbon. If that number within that hydrocarbon is an odd number, if it's an odd number, I promise you're going to have to reduce all these values. Okay? I promise. If you stick to the idea that I'm going to have an even number of water molecules. Okay? So after we balance every equation, we always check and ask ourselves, is this the smallest whole number ratio? Okay? And since we have a 29 here, absolutely it is. Okay? All right, and I hate to say it, guys, this is as ugly as the problems get. Okay, so These are the ones that we just absolutely love. All right. Number 2, write a balanced chemical equation that describes each of the following. Now, what's different about this is you get to write the formulas, which is good practice. Okay. Copper metal. How do you write copper metal? Well, hopefully you write Cu. Okay. Reacts with oxygen gas, which again, if it ends in gen or INE, if it ends in that and it's all by itself, it is diatomic. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That's iodine. But if it ends in INE, okay, those are the, I think it's 7 of them. Those are the ones that are diatomic when they're by themselves or they're with their own kind. Okay. Now, if you have something like this, which we're about to make, copper oxide, okay, there may not be a subscript. We'll see here in a second. All right, so we take copper and oxygen gas and form copper 1 oxide. All right. Now, here's what we want to do, just like what we talked about in an earlier video. We want to represent each element first and then place the charges on there and balance. So we have to balance the formula first. You have to balance the formula first before you can balance the equation. So copper has a +1 charge. How do I know that? Because there's a Roman numeral 1. That doesn't mean there's 1 copper. That means the charge on the copper is +1. The oxide, well, the oxygen will always have a -2. Where did I get that? Well, if I look on my periodic table, I'm 2 spaces away from neon, which means that oxygen wants to gain 2 more electrons to have the same electron configuration as its nearest noble gas, which in this case is neon. So if I look at this, that does not equal 0. So that means I need 2 coppers. Okay? So it's Cu2O. All right, now, if you want to do the inventory method, that's fine. Let's see, make sure I have enough room here. So I have 1 copper. I have 2 oxygen. I have 2 copper. I have 1 oxygen. Oh, isn't that convenient? So how can we do this? Well, start off with the ugly ones. Now, in this case, since it's not a hydrocarbon, you don't have to save oxygen for last. Actually, if it's not a hydrocarbon, I usually start with oxygen because it's one of those weird scenarios. But again, you start with what you want because you're using a pencil and an eraser, and you're going to make it right. So I'm going to start off with the oxygen here. Since I have 2 here and only 1 here, I'll put a 2 right there. So now I have 2 oxygen. But now how many coppers do I have? That's right, 4. My oxygens are good, so let's fix my copper by making a 4 there, which means I put a 4 there. Okay, pretty simple. We like that. All right, heptane reacts with oxygen gas to produce carbon dioxide and water. Now, if you don't remember what heptane is, then you can go back and look at your notes. This is examples and homework. Again, I'm not going to ask you to be able to memorize that for the first test, but I would like for you to know what that formula is for the AP exam. So heptane, here I'll give you a hint. Heptane, hep means 7. Very good. So that means we have 7 carbons. And since it ends with A and E, that means that my number of hydrogen is twice as many carbon plus 2. So 2 times 7 is 14, and then add 2 more, which is 16. So there's heptane. Reacts with oxygen, and again, this is a combustion reaction, so we better produce the same stuff that we're breathing out, which is carbon dioxide and water. Okay. And again, honestly, I don't know how to balance these types of equations out other than using the inventory method. So I've got 7 carbon, 16 hydrogen, and 2 oxygen. And there are no oxygens in this compound, the heptane. Carbon I have 1, hydrogen I have 2, and oxygen I have 3. Okay? So, as true to form, let's leave the hydrogen, or start with the hydrogens over here. So I have 16 over here. So to get 16 on this side, I'm going to put an 8 right in front of there. And that is an even number, so I don't have to double it, which is pretty nice. Okay, how many oxygen do I have? Well, I have 2 plus 8 times 1, which is 10. Okay. Carbons. So I have the same number of hydrogens on both sides. Carbon, I have 7 over here. So let's put a 7 right there. Alrighty, so now I have 7 the oxygen. 7 times 2 plus 8 times 1. So 14 plus 8 is 22. Wow. Guys, that's why we can't have a long summer break. The simple math skills go by quick. Alright. Alright, so we have same number of carbon, same number of hydrogen. We want to get 22 total oxygen on this side, so we need an 11. Okay? Alright. Letter C. I think it's the last one. Yeah, letter C. Try this one on your own. Try this one on your own. And just like all these examples, hopefully you've been attempting these on your own and then checking the answer. So go ahead and try this and then start the video up again. Alright, you've had a chance to try it. Lead 2 nitrate, which is Pb. Oh, I'm sorry. Lead plus 2, nitrate minus 1. So NO3, need 2 of those. Reacts with sodium phosphate. And again, plus 1, minus 3. So sodium, put a plus sign in there. Sodium, oh, don't need a parentheses there, Bubby. PO4. Yeah, don't be putting parentheses where you don't need them. Sodium phosphate to produce sodium nitrate. Again, it's a double replacement reaction, so the partners are going to switch. So sodium nitrate. Now, here's one thing that a lot of students pick up a bad habit, and I don't like it. Never ever carry subscripts unless it's attached to a poly. Okay? Those are the only subscripts we ever carry. Never ever carry subscripts outside of a parenthesis, or never carry subscripts that are next to an element. Okay? If it's within the poly, like nitrate, bring it with it. Everything else, leave behind. So we're going to write one of each here. So sodium has a plus 1 charge, nitrate has a negative 1 charge, so it's balanced as written. Pretty nice. And then lead 2 phosphate. I'm actually going to scrunch it down here. Lead has a plus 2 charge, phosphate's negative 3, so that means I need 3 of these. And phosphate, I need 2 of those. Okay? And I did that because I knew that I would write that bigger. Okay. So I have my formulas written correctly, and they're balanced. Now I need to make sure that I have the same number of atoms on both sides. And again, do we have polys? Oh, baby, we got a ton of polys on this one. This is nice. Okay, so let's go ugly early and look for the one that has the most subscripts. Here we go. Lead 2 phosphate. So I would start with that one. So, and it doesn't matter if you want to start with the phosphate or the lead. Why don't we start with the lead since we have not done that before? So there's 3 leads here. There's 1 lead here. To balance that out, put a 3 there. Okay. Alright, so we have 3 leads on both sides. So my leads are good to go. How many nitrates do I now have? I have 2 here times 3, which is 6. So I'm going to put a 6 here. Okay, so my lead and my nitrates are now balanced. How many sodium do I now have? I have 6. How many do I have over here? I have 3. So I need 2. And then balance the phosphate. I have 2 phosphates. I already had 2. I'm balanced. Okay. I'm trying to remember if I have more types of examples online. I'll take a look and see. If I do, I will definitely post those. But the homework should keep you busy for a while. So, as always, I hope this video has helped.